الليكتشر دي احنا معانا انجينير ياسين بارتاي صح؟ ده اللي انا قايله الاسم صح؟ He's online و هو he's an engineer ومعاه دكتور جهاد محمد أبو المجد. Lecture title Tips of Radiation Protection in Dental Radiology. وأهلا بيك. أهلا بيك.
السلام عليكم. كيف
عليكم
حالكم؟
السلام. أهلا.
الله يخليك. شكرا.
تقدر تبتدي حضرتك، اتفضل.
الله يخليكم. شكرا. But I think maybe I have to cut my camera just for some practical. Should I keep it on or I can turn it off?
Keep it. Keep it.
Yeah. Okay.
It's nice to see you.
Okay. Yeah, I will try because I have double screen. Okay. Up. Okay. So, do you see my screen?
No. You need to share the screen. Share it.
I think I shared my screen.
You can start your presentation.
Okay. So, hello. السلام عليكم جميعا. أتمنى تكونوا بخير. يسعدني أن أكون جزءا من هذا الإيفنت AIRC 2025. أقدم الشكر للدكتورة جهاد على الانفيتيشن. كنت أريد أن آتي وأزوركم في مصر ولكن next time إن شاء الله. So my name is Yassine Bartai. So I am a sales manager within Corning of the radiation shielding glass. So today I will interact as we can say a technical person, not as a sales manager. I work closely with X-ray specialists, radiologists, and also doctors to choose the right materials that is suitable to their needs of radiation protection. So my goal today is to help you better understand transparent radiation shielding glass materials and how they work, and also to share some we can say characteristic of this product that ensure the safety and also transparency for doctors and also physicists. So So in the coming 10 minutes, I will start just with a brief introduction of Corning. So I will briefly introduce our main business and the radiation shielding glass, and also what are parameters that make it effective in a radiological room, and how to select the raw material and thicknesses. So I will keep the discussions practical and application-oriented, based on some situations and example that you may encounter on your daily practices. So just briefly, Corning, there are some key numbers about Corning. So Corning, we are a material science company specialized in different materials. And we have 77 manufacturing sites with dozens of center of R&D facilities, and we invest around 10% of our turnover in the research and development. So we try to be really active, and Corning is also present in many aspects and modern lives. So as you can see here, we have a wide range of products. It starts from screen of mobile phones, optical fibers networks, pharmaceutical vials, and advanced medical systems. In healthcare, this innovation supports diagnostics, imaging, and treatment. So today, the focus, of course, is the radiation shielding glass, because as you are a radiologist and doctors, so the idea and the target is to share with you what we can help you in your daily practices. So the radiation shielding glass today that we offer covers many applications. So it could be used in X-ray rooms, in nuclear medicines, where injection of radioisotope is carried out, and also it could be used in some nuclear applications. And the main target also is always to protect doctors and also radiologists and scientists and veterinary during their daily practices. So across all these applications, the challenge is the same: protecting medical staff from ionizing rays. So we have different materials that are aimed to protect against X-rays and also gamma rays. And as you see here in the picture, there are 5 types of rays, and from our side, Corning, we develop specific materials to shield against X-rays, gamma rays, and sometimes against some neutronics. We can say neutronics shieldings for nuclear applications. So at Corning, as you can see, our product ensure and also provide safe and reliable transparent radiation protection. And we have many techniques, and the right we can say product depends, of course, on 2K parameters, the X-ray tube voltage, and also we can say the lead equivalence required to ensure the radiation protection against the children, against the in the X-ray room against this kind of rays. So here there are some, we can say, some properties of the radiation lit glass. So the target is to use, we can say, heavy material, because finally what ensure the radiation protection is, we can say, the heavy oxide that are used inside this composition, and they have, we can say, a high power of absorption, and so they absorb rise for we can say higher against higher we can say and more powerful equipment imaging. And the product, of course, the main idea is to protect against rays. So each plate that we supply, it's controlled under the international standard IEC 61231. So we use the narrow beam method. So each plate is controlled to ensure that the product is compliant and ensure the lead equivalence required in we can say in specific applications. So the questions here is to see how to choose the right materials to achieve the target of children performance, because we may have different materials that are available in the market. So here, for example, in the lifts, you see that there are other materials than lead glass that are used in X-ray rooms. For example, here we talk about lead acrylic. It's, we can say, a polymer resin that has characteristic to absorb X-rays and gamma rays. In the right here, we have pure lead sheet. So the problem of lead is we can say it's not transparent. So it's opaque, it's a heavy material, and the problem is also toxic in touch, because sometimes here in Europe, for example, we have some difficulties to use this material due to its toxicity. And also in parallel, the other materials in the right, polymer is a flammable product, so it's sometimes it refuses to be used in installations in hospitals. So as you can see here in the middle, we also supply Corning supply the lead glass, which is, we can say, the most suitable product that ensure both safety and transparency for doctors and the radiologists in hospitals room. So the questions is how we choose the right techniques to achieve the children's level in hospitals room. So there are two key parameters. So the first parameters here is the X-ray tube voltage and the lead equivalence required. So, for example, here in this example, we can say equipment, scanning equipment, emitting some high doses of X-rays and which is working under 1.5 kilowatt, for example. And in this, we can say a room, the designer or the architect specified that the required children to ensure safety inside the room is 2 millimeter. So this both key parameters define the right techniques of the product that you need to use to ensure safety in X-ray room. So as you can see, here it's also an example of a standard, we can say a standard example that we have in a daily, we can say daily practices in hospitals, for example. So here we have a big viewing windows, and behind the screen we have equipment, imaging equipment, which is working under 1.5 kilowatt, for example. In 10, the radiologist has, we can say, different choices. So he can use lead acrylic, for example. He can use lead glass, and also he can use only pure lead. But the problem here for the doctors or radiologists, or maybe the dentist, is he needs to continue supervising the operation inside the room. So the first thing is that he needs transparency. So there is only, we can say, these three materials that could ensure the transparency. But the problem, for example, for the lead acrylic has low light transmissions. So the visibility is not optimal. It's not optimal, and sometimes the material will brown when it's exposed to the X-rays after, we can say, some durations of utilization. So the only, we can say, the only suitable solution that remain and that could ensure safety and also to high transparency is the lead glass, so inside the room. And with Corning, our strength in the market is that we use a thinner plate of glass. So when we say thinner plate, that does mean that the white is low, and then it's easy to install, and also sometimes it's easy to transport inside the room, for example, for the user. For example, for the mobile shieldings, sometimes during the surgery, for example, doctors need to move and also to move the mobile shielding inside the room. So when the mobile shielding is heavy, sometimes it's difficult. So we need to put more strength to move. And we can say our strength is that we supply thinner product with we can say lower thicknesses, which is the best combination finally, and which is really useful for daily practices. So here, for example, in this slide is an example also is an extract of French standards. The name of the standard, the regulation is NFC 15160, and it defines the children that should be respected around scanner, for example. So here you can see the scanner. He is in the room and he is emitting rise in doses inside the room. So,
engineer Yassine, we run out of time.
sorry. So I will, sorry, I will speed
I'm
up.
really
So
sorry.
maybe I will. I have how many minutes still, or
No,
we need to close?
you extended more, 3 minutes more. You extended.
Okay, okay, sorry. So I will go directly to the closing. So yeah, thank you very much for your time. So just to close, we can say the presentations, the radiation glass from Corning is designed for long-term use, and we try to find solutions for radiologists and also doctors inside the X-ray rooms. So our role, of course, is to support you and support professional in healthcare sector with reliable and certified children product. So thank you very much for your time and your attentions, and don't hesitate to join me or to send me an email if you have any further questions. Thank you very much for your time, and may apologize
Thank
for
you very
the
much.
long
Thank you,
presentation.
Dr. Gad.
You are welcome. Thank you very much. Have a good luck. Thank you. Bye bye.
Welcome.
Bye.
Thank you, Doctor.